Drum cans are essential components in various industries, providing reliable storage and transportation solutions for liquids, powders, and other materials. They are ubiquitous in industries such as chemical manufacturing, food processing, and oil and gas. Their strength, durability, and versatility make them indispensable for storing and transporting various substances. Understanding the manufacturing process of these durable containers sheds light on the intricate steps and high-tech processes involved in their production. In this video, we'll take you through the detailed journey of how drum cans are made in a modern factory, from raw material selection to packaging and distribution. But before then, let's take you through on how raw materials are converted to steel, which is used in the production of drum can. Steel coils are significant material for various manufacturing plants producing home appliances and other industrial products. Let's take you on a virtual tour of the state-of-the-art Dearborn Steel manufacturing plant. This is a major producer in the U.S., specializing in the production of flat-rolled products, including hot-rolled band and hot-rolled processed sheet, cold-rolled sheet, hot-dipped galvanized sheet, electro-galvanized sheet, aluminum-coated boron, and other advanced solutions. Modern Innovative won't keep you waiting any longer. Let's get started on this fascinating journey. This is the company's or yard. After being mined, steel ore is gathered here to prepare for the next production steps. The plant is equipped with a modern production system featuring many automatic and high-performance technologies. One of the critical pieces of modern steel production is the blast furnace you are seeing. This furnace is essential in transforming raw iron into steel. The blast furnace operates at extremely high temperatures, allowing the extraction of pure iron from its ore. Next is the basic oxygen furnace, a common technology in steel production. More than half of the world's steel is produced using the basic oxygen process. The basic oxygen furnace is a refractory line tiltable converter into which a vertically movable water-cooled lance is inserted to blow oxygen through nozzles at supersonic speed onto the charge. The use of pure oxygen at high flow rates results in such rapid oxidation of the elements contained in blast furnace iron that only around 20 minutes are required per heat to refine one charge. Converters vary in size and are designed for heats ranging from 30 to 360 tons. The Dearborn 68-inch hot strip mill has an annual throughput of 3.8 million tons, 3.5 million metric tons. The hot strip mill can roll steel to a minimum gauge of 0.050 inches, 1.27 millimeters, and widths from 30 inches to 61 inches, 762 millimeters to 1,549 millimeters. Dearborn cold-rolled steel is available in thicknesses from 0.014 inches to 0.110 inches, 0.36 millimeters to 2.79 millimeters, and widths from 28 inches to 61 inches, 711 millimeters to 1,549 millimeters. The cold-rolled steel yield is approximately 1.8 million tons per year. These plants produce a variety of products, from home appliances to automotive parts, utilizing the high-quality steel coils from the Dearborn facility. After the production of steel coils is completed, they are transported to manufacturing plants where they are used for drum cans. Upon arrival, they undergoes quality check. High-quality steel is chosen based on its mechanical properties, including tensile strength and uniform thickness. It must be free from impurities and defects that could compromise the drum's performance. Steel suppliers must provide certification and documentation proving that the materials meet industry standards and specifications. Once the quality check is completed, the steel sheets undergo preparation processes to ensure they are ready for manufacturing. The steel sheets are cleaned to remove any contaminants such as oils, dirt, and residues from the milling process. This step ensures better adhesion during welding and coating. The sheets are then flattened to ensure uniform thickness, which is crucial for achieving precise cuts and shapes in subsequent stages. Flattening machines use rollers to smooth out any imperfections. The prepared steel sheets are then cut and shaped into components that will form the drum can. Automated cutting machines, such as laser cutters and shears, are used to cut the steel sheets into specific shapes and sizes with high precision. These pieces include the drum body, lid, and bottom. Precision cutting is key to ensure all components fit together seamlessly. Tolerances are kept within strict limits to prevent gaps or overlaps during assembly. A short time later, these exact steel segments must be twisted to make the empty groups of the barrels utilizing moving machines. As their name proposes, these units highlight rollers which pivot in inverse bearings while packing the metal sheets. This makes the steel segments progressively bend and structure the round and hollow profile of the barrel drums. The longitudinal open closures of the shapes are then fixed through an interaction known as obstruction welding. The welded creases guarantee the cylinder-like vessels stay watertight. Additional shaping includes creating the chimes, reinforced rims, on the top and bottom of the drum, which provide added strength and facilitate stacking. To make covers and bases, a machine called a punch press is utilized. A segment of the steel sheet is sandwiched between the upper piece of this machine, known as the punch, and the lower part, known as the bite the dust. The punch strikes the metal down into the kick the bucket, framing the state of the top or base. The whole interaction requires only seconds to finish. After the bases are perfectly cut out, the edges are filed and smoothened. The conveyor belt transfers the bottom drum base to a machine that stamps a serial number on each and every drum base. At long last, the punch-squeezed covers and bases are connected to the barrels, finishing the gathering system. Every top or base is either precisely or physically put on top or lower part of the chambers before a roller machine smooths the edges down to make seals known as rings around the barrel's edges. This step is critical for ensuring the drum is leak-proof and robust. The completed barrels are then quality-tried utilizing compressed air to check for openings that could bring about spillage. To protect the drum cans from corrosion and enhance their durability, they undergo surface treatment and coating processes. Some drum cans are galvanized, a process that involves coating the steel with a layer of zinc to prevent rust and corrosion. The zinc layer acts as a sacrificial anode, protecting the steel underneath. Other drums may be painted or coated with specialized materials to protect against environmental damage and chemical exposure. Epoxy and polyester coatings are common choices. Coatings can be applied using spray painting, electrostatic painting, or dipping, depending on the specific requirements of the drum and its intended use. Quality control is a critical aspect of drum can manufacturing. Each drum undergoes rigorous testing to ensure it meets industry standards and performs reliably. Drums are subjected to pressure tests to ensure they can handle the required load without deforming or leaking. Drums must comply with industry-specific regulations and standards, such as those set by the American National Standards Institute, ANSI, or the International Organization for Standardization, ISO. Once the drums pass all quality control tests, they are prepared for packaging and distribution. The finished drums are cleaned to remove any residues from the manufacturing process. Drums are labeled with important information, including their specifications, usage instructions, and safety warnings. The packaged drums are then shipped to various industries, where they will be used for storage and transportation of a wide range of materials. The manufacturing process of drum cans involves a series of meticulously controlled steps, from raw material selection to final distribution. Each stage is critical to ensuring the drum's durability, safety, and reliability. By understanding this process, we can appreciate the advanced technology and precision engineering that goes into creating these essential industrial containers. Whether used in the chemical, food, or oil and gas industries, drum cans provide a robust and versatile solution for storing and transporting materials, making them a cornerstone of industrial operations.